Okay, welcome to the video for lesson 5, measuring variability for symmetrical distributions. So we're going to do something today called calculating the standard deviation. Your calculator has the ability to do this, but there's definitely some value in understanding how to do it in case you ever have a calculator that doesn't. So here's a dot plot for the brand A batteries. So this kind of goes back to one of the previous lessons where we were talking about brand A, brand B, C, D. I think we went all the way up to E. How do you measure variability of this data set? One way is by calculating standard deviation. Okay, so now we're going to be focusing on variability, not measure of center, but variability. First, find the mean or find the deviation from the mean. So actually before that, you'd have to know what the mean is, okay? And the mean for this, I believe, is 101. We actually found that in a previous lesson. So let me write that down. The mean is 101. And you could simply find that by adding up these values, 93 or 83, 94, 96, 106, 113, and 114, and then divide by how many there are. There's 6 of them. All right, so we're going to find the deviation from that, which is actually already done in this table here for us. Then square the deviation from the mean. For example, when the deviation is negative 18, the square of it is 324. In other words, we're going to end up with a positive number. So all of that has been done in this table for you. The deviations, which we actually found in a previous lesson, and then the squares of all of those. Now, we're going to add up all of these. So we get a total of 736. Now, if we were to just, actually, I'm wrong. I was about to say if we were going to divide by 6, we would find the MAD. I was wrong because if we wanted to find the MAD, we would actually just take these negative numbers and find the absolute value, so make them positive. So 18, 7, 5, 5, 12, and 13. If we wanted to find the MAD, we'd add up those numbers and divide by 6. Remember, the MAD is the mean absolute deviation. But in this case, we're going to be finding the standard deviation, which is a little different. So we square those numbers. This result is the sum of the squared deviations. Okay, now the number of values in the data set is denoted by n, so there's 6 of them. Now here's where there's a key element to this that a lot of people are confused by. You divide the sum of the squared deviations by n minus 1, which here is 6. So 6 minus 1 is simple, it's 5. Now a lot of people are confused. Why do you do that? Why not just divide by 6? It's actually kind of complicated. If you end up taking a course in high school called AP Statistics, you'll understand a little bit more about that. If you don't, if you ever take a college level statistics course, again, you'll learn a little bit more about that. Essentially, your job right now is just to understand and do that, and you'll be given the information, n minus 1, so you won't have to remember it. You'll just have to be able to do it. But basically, you get closer to a typical or standard deviation by using n minus 1 instead of just n. So finally, you take the square root of that answer. So it's kind of like we're going backwards now, or the reverse of what we did earlier, squaring. We take the square root. It's not going to be, well, it could be a perfect square, but in this case, it's not. So we round it to the nearest hundredth, which is 12.13. So we conclude, let me get my highlighter. We conclude that a typical deviation of brand A battery life from the mean battery life for brand A is 13 or 12.13 or 13 hundredths hours. So that's it. We're going to actually practice this together here on the next page. Let me pause the recording and get this set up, and we'll be right back. All right, folks, and we are back. So now on page 32, we're going to actually do this on our own. I'm going to start you out and walk you through the first one, maybe a second one. And then I'm going to expect you to do the rest of the table on your own and come back and we'll obviously compare answers. So to do this, you're going to need a calculator. So make sure you have your calculator app open. I have mine open and ready to go. Look at that. I already did the first one. So our first value here is 73. We know our mean is 100.5. That is given to us, but we found it in a previous lesson anyway. So if you wanted, you could add up all these numbers and divide by 8 and get it. But we don't need to do all that. So we have our answer of negative 27.5. Now, next step is to square that. What's nice about the calculator is all you have to do is hit this little x to the second power button, and notice it substitutes the answer in for you. Obviously, you could type in negative, make sure you don't hit the minus, you hit the negative 27.5 and then hit the same button, or use the caret in the 2 key, any way that you prefer, and then hit enter. And we get 756.25. So I'm going to come back and I am actually going to type that in, 756.25. All right. Now we're going to do the same thing for all of these. So again, I do 100.5. Well, we actually already have all these deviations done. So now we're going to just simply type those in and square them. So let me do negative 24.5, negative 24.5. Hit that X to the second power button, enter, and you get negative, I know what I did wrong. I needed to use parentheses with my negative. So you should not get a negative answer with this. If you do, you did something wrong like I did. Calculators are not smart. They actually need you to be smart. So parentheses are necessary for this to work. So we get 600.25. All right. And then another way of doing it is for this last one, we've got, again, parentheses, negative 8.5. Oops. And then you could use the caret and then to the second power. Enter. 72.25. All right, finish the rest of the table on your own. I'm going to pause the recording. When we meet up, we'll compare answers. Okay, so I finished filling in the table. Check your answers with mine and make sure that I didn't make any mistakes and you didn't make any mistakes. If you have something different, double check it. Maybe I did something wrong. Okay, so next, number 2, add up the squared deviations. In other words, we're going to find the sum of the deviations, which is 2,692. Okay, what is the value of n for this data set? Well, there's 8 of them, so n is equal to 8. So that means n minus 1, which is the value I really need, is 7. So what I'm going to do is I'm going to take that 2,692, and divide that by 7. And I'm going to round that to the nearest thousandth. I actually want to go at least one step or one place value beyond what I'm going to end up rounding to in the end. So I go to the thousandth. So that means I do wavy equal sign, which means about or approximately 384 and 571 thousandths. Okay, so now I'm going to take the square root of that. Remember, it's that symbol there. Square root or radical, if you like that, 384.571. And that is going to be approximately, let's check it out. Let me clear my calculator. So I'm going to hit second x squared button, and you'll see there's your radical. 384.571, enter, and there you go. I'm going to round it to the hundredths, so that's a 1. It's a 0 after it, meaning my answer is 19 and 61 hundredths. And then this is hours. That's our label, hours. Okay. So how are we going to answer? How would you interpret the standard deviation that you found in exercise 4? So we're going to put this in context of the question. So the standard deviation is 19.61. Oh, that is 19 hours is a typical deviation of brand B battery lifetime from the mean, from the mean for brand B batteries. There you go. That's it. All right. So over on the next page is another exercise of doing this on your own. Jenna has bought a new hybrid car. So you need to calculate the standard deviation for these results. First thing you got to do is find the mean, then find the deviations from the mean, then do all the calculations. I'm going to pause the recording. When we come back, I'm going to have all the information done and we'll compare our answers. So you need to try this on your own. Okay, we are back. So first thing for Jenna's hybrid car, we had to calculate the mean. So you add all these up, and there's 1, 2, 3, 4, 5, 6, 7 of them, and divide that total by 7. I got 44. Next, you find the deviations from that. So 45 minus 44 is 1. 44 minus 44 is 0. 43 minus 44, negative 1. 0, 1, 0, negative 1. Kind of some nice numbers to work with here. Now I square all of these. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1. 0, 1, 0, 1. Add them up. 1 plus 0 plus 1 plus 0 plus 1 plus 0 plus 1 is 4. Now I divide by n minus 1. So first, n is 7. So n minus 1 is 6. 4 divided by 6 is 0.6 repeating. Or if I round it to the thousandth place, 0.667 approximately. So now when I take the square root of that, I get 0.82 or approximately 0.82 miles per gallon. So the standard, question 7, what is the meaning of the standard deviation you found? The standard deviation, 0.82 miles per gallon, is a typical deviation of weekly fuel efficiency value from the mean weekly fuel efficiency. So if the mean is 44, typically it's 0 or 1 above or 1 below. So I think our value makes sense, 0.82. It's not quite 1 because we have a couple of zeros in there, but we have more ones or negative ones than zeros. So that's a pretty good indicator. So that's it for this lesson, pretty short. Hopefully you understand it. If you don't, ask questions and we'll see you in class.